Hello friends, myself ASHWINI from Institute of Medical Sciences and you are watching ASS Tutorials. Today we are going to start nucleophilic substitution reaction through addition followed by elimination, that is SNA. You must have watched the introductory video about substitution reaction. If you have not watched that video, please go and watch. That video is placed in your playlist GOC2 Organic Chemistry. So please watch that introductory video on substitution reaction. You will get a better idea. Okay, so we are going to start with SNA. Before starting, I request you to please subscribe my channel and share with your friends. If you like the video, at the end please click the like button. Now we should start with nucleophilic substitution through addition and elimination. Catch up the words. First is nucleophilic substitution through addition, means nucleophile will be added, okay, followed by elimination of something will be eliminated, a nucleophilic part will be eliminated. See, so nucleophilic substitution through addition followed by elimination means something will be added and something will be eliminated, and that mechanism is discussed under your SNA. And acid derivatives will give this type of reaction. Okay, SNA example is your substitution reaction of acid derivative. We are going to discuss mechanism, you will get more idea about that. See, this is your compound acid derivative, any acid derivative, okay, Z may be your okay, any we will discuss in detail. So now starting with this is your reagent electrophile, nucleophile. Okay, nucleophile have negative charge, electrophile will have positive charge, and this bond RC double bond O Z. See here, this bond here delta positive charge is developed. Okay, so the first will be attacked by nucleophile will attack on the positive charge. As you all of know that nucleophile loves nucleus means it loves positive charge. So this nucleophile will attack on this carbon because this carbon has delta positive. Okay, this carbon has delta positive and this oxygen has delta negative because En of oxygen is more than carbon. So the nucleophile attack will be on this carbon. And if nucleophile is going to attack on this carbon, see, this carbon has 4 bonds, 1 2 3 4, and carbon can made only 4 bonds, not more than 4 bonds. Carbon has not capacity to make more than 4 bonds. So carbon is making 4 bonds. If nucleophile is attacking here, then there is must a breakage of 1 bond so that this carbon can make bond with this nucleophile. Again, this carbon can make maximum of 4 bonds, maximum of 4 single bonds. Okay, this is the limit of carbon. So if nucleophile is attacking this carbon, why nucleophile is attacking this carbon? Because nucleophile wants to make bond with carbon. Nucleophile wants to make bond with carbon, and if carbon and nucleophile bond is created, then there will be extra bond is getting formed, but carbon have maximum of 4 bond. So there must be breakage of one of these 4 bonds. Clear? There must be breakage of one of these 4 bonds. So once the nucleophile attack here, okay, this 1 bond is opened up and its 2 electron goes on the oxygen. So this will be the structure RCO negative because of the electrons, and here nucleophile bond is created and here Z. Clear? Now this oxygen has a negative charge, and we know charges always create instability. Whether it is negative charge is stable on high N atom, but charges always create reactivity, that is leading to instability. So oxygen wants to remove its charge, so oxygen will try to put this electron to form bond with this carbon, but this carbon can make only 4 bonds. I have earlier told this is the limit of carbon. So once its electrons come into this place, this Z, if it is leaving group, this Z, I have taken assumption that this Z is your leaving group. This Z is your leaving group means it will leave upon the requirement. Z is a leaving group means it will leave upon the requirement of the reaction. Okay, so once this electron comes to make bond with this carbon, means oxygen is going to make double bond with this carbon, this Z group, okay, this Z will leave here. So see, if this bond is going, so this bond can be formed because carbon can form maximum 4 bonds. So this was the 1 2, this is the 3, and this extra which is going to form is your 4th bond because this bond has been removed. Clear? So the reaction will like that, RC double bond O, okay, and nucleophile. This Z group is removed. Mind it, this Z group must be your leaving group. This Z group must be your leaving group. Until and unless the Z is not a leaving group, the Z is not going to leave this bond, and if Z is not going to leave this bond, then oxygen have negative charge. Oxygen will not make that bond by removing its charge. Oxygen is not able to remove its charge, so oxygen has to find another way to remove its charge. Mind it what I have said, if this Z will be not a good leaving group, if this Z will not be a good leaving group, then oxygen has to find another way to remove this negative charge. What he is doing now, oxygen is making double bond by putting its extra charge, okay, double bond with carbon, and the product is here. But this product is formed due to the mercy of Z group, because Z is living, Z is a living group, it is living, okay. To see the demands of oxygen, to fulfill the demands of oxygen, Z has left the compound. Z is your saint, okay, he is sadhu, he is living. So this is the basic concept I want to stress upon it many times. If Z is a living group, okay, then it will live, and then oxygen can form double bond with carbon as earlier. But if Z is not a living group, then this oxygen cannot form double bond with carbon. Oxygen has to find another way to remove its charge. Now we are going to find what is the another way oxygen have to remove this negative charge. Now coming for that, this is the basic idea. If you are getting these ideas, okay, you will solve all the questions of nucleophilic substitution, and you will never be confused into nucleophilic addition reaction and nucleophilic substitution reaction. You will never be confused in nucleophilic addition reaction and nucleophilic substitution reaction. One thing before starting, one thing you know that nucleophilic reaction, in previous videos I have told by mistake nucleophilic addition reaction, but mind it, in nucleophilic reaction will be occurring in those reagent which have multiple bond with different En atoms. Okay, if multiple bond is present between different En atoms, then those group of reagent will always give your nucleophilic reaction. And again, nucleophilic reaction is divided into nucleophilic addition and nucleophilic substitution. Okay, I will tell the reason how to identify which compounds will be undergoing nucleophilic addition and which compound will be undergoing nucleophilic substitution, what is the basis of that. But first you have to identify that which reaction is going to give electrophilic reaction and which of the compounds is going to give nucleophilic reaction. The nucleophilic reaction is occurring in those reagent which have multiple bond with different En atom, means like that of your carbonyl compound. See here, this is your multiple bond, that is double bond between two different En atom. Two different En atom means this is carbon, this is oxygen, and both have different En. Now electrophilic reaction is shown in multiple bond with same En atom. Okay, with same En atom. In those compounds you will find electrophilic reaction. How? I am giving example. You have seen alkene. Alkene has C double bond C. It means multiple bond, that is double bond, is present between two same En atom. Both are carbon and both have same En. So if multiple bond is present between two same En atom, then this compound are going under electrophilic reaction. Okay, and again electrophilic reaction is divided into electrophilic addition and electrophilic substitution. So electrophilic addition reaction was of alkene and alkynes, and electrophilic substitution reaction is of benzene. Substitution reaction on benzene ring is coming under electrophilic substitution reaction. Clear? So this is the basic idea, the most important idea of the organic reaction is this. Okay, how you will identify nucleophilic reaction and electrophilic reaction. Okay, now we are going to focus. We have identified then which of the following reagent is going to give electrophilic, which of the following reagent is going to give nucleophilic. Now we are going to identify which of the nucleophilic reaction are nucleophilic addition reaction and which of the nucleophilic reaction are nucleophilic substitution reaction. The previous mechanism which I was discussing is of nucleophilic substitution reaction. Means if Z is a good leaving group, then those reactions will be under nucleophilic substitution reaction, and if Z is not a good leaving group, then those reaction is going under nucleophilic addition reaction. We are going to discuss that in detail, so wait. And one more thing, why I am saying that if multiple bond is present between two different En atom, then those compounds will undergo nucleophilic substitution reaction. Its reason I have discussed in my first video of organic reaction, so go and watch that first video, you will get idea why, means reason behind this. Okay, I am not discussing reason, I am discussing direct conclusion of that video. Now we are going to identify which of the following compounds are going to give nucleophilic addition reaction and which of the following are going to give you a nucleophilic substitution reaction. So suppose this was your reacting molecule, okay, and here nucleophile attack, nucleophile is there. Then there will be two methods, I have told many times. First one is your that nucleophile will attack, okay, and this open this bond, okay, and now no, I don't want to open here, okay. So nucleophile attack is there. If Z is a good leaving group, if Z is a good leaving group, then the product will be your RC double bond O nucleophile. And if Z is not a good leaving group, I am not going to again discuss this mechanism because I have discussed that mechanism, okay. Now Z is not a good leaving group. If Z is not a good leaving group, then what will the mechanism? Then the reaction will be nucleophilic addition reaction. How? See here, RC double bond O Z. This is not a good leaving group, okay. Here nucleophile, electrophile. So nucleophile will attack on this carbon, the bond will be open here. So this is your RCO negative charge Z, and there is a nucleophile. Now this negative charge will try to form double bond with carbon to remove its negative charge, but this Z group is not ready to go outside because it is not a good leaving group. It is not a good leaving group, so Z will not go outside of the molecule. So O has to find another way to remove its charge. So what will O do then? Then it will capture electrophile. It has positive charge, it has negative charge, so they both will be attracted towards each other, and the product will be this compound. And this was a basic idea in which we have completed nucleophilic addition reaction with simple this mechanism, okay. And when Z will not be a good leaving group, if Z is hydrogen or Z is alkyl group, I am again telling, if Z is hydrogen or Z is alkyl group, then the Z is not a good leaving group, then these compounds will undergo nucleophilic addition reaction. And we have seen that carbonyl compound, that is your aldehydes and your ketones, undergo nucleophilic addition reaction. We have discussed that nucleophilic addition reaction is given by aldehydes and ketones, cyanides too, but aldehydes and ketones are the main focus because you have to differentiate between this group C double bond O. So if the Z is your hydrogen or R, if Z is hydrogen, then that will be aldehyde, and if Z is R, then that will be your ketones. So remember like this, if aldehyde and ketones are there, then the reaction will be nucleophilic addition reaction, because H and R, here H or maybe R means CH3, CH2, CH3, any of this, methyl, ethyl or any other group, H and methyl alkyl groups are not the good leaving group, so it will not leave. So the reaction will be done by your nucleophilic addition reaction, okay. But when Z is a good leaving group, in acid derivatives, the Z will be a good leaving group, then it will be undergoing nucleophilic substitution reaction. So please note it down. This is the basic mechanism, okay. This is the base of your organic reactions. If you are understanding this, which compounds are going to give electrophilic reaction and which compounds are going to give nucleophilic reaction, and again in nucleophilic reaction, if you are able to differentiate between nucleophilic addition and nucleophilic substitution, then sure you will going to get a good marks in your organic chemistry, and you will not fear anymore in organic chemistry, okay. Because so we are going to take some questions based on SNAE mechanism, okay. Now see, you are knowing the basic mechanism, how the product was forming on, you can easily do all the questions. I have taken 8 questions. First I am going to tell you about what is, I am telling frequently that acid and acid derivatives means you have to RC double bond OX, acid halide, amide, okay, anhydride or ester. These are the 4 which are coming under your acid and acid derivatives, and mainly you will find reaction of halide, anhydride and ester, because this amide is very least reactive towards SNA, because NH2 is a very bad leaving group. Okay, now coming to the question. The question is your basic, these are the reagent 1 to 8. Okay, and this is your reactant CH3 C double bond OL. I am again writing here CH3 C double bond O Cl. First you have to find that which type of, how you will proceed for a question. How you will proceed for a question I am going to explain. Please watch it carefully. First you have to identify that reaction will be nucleophilic or reaction will be electrophilic. How you will identify? If reaction will be nucleophilic, then there must be presence of multiple bond between two different EN atom. There must be presence of multiple bond between two different EN atom. And if the reaction is going to be electrophilic, then multiple bond must be present between two same EN atom. If multiple bond is present between two same EN atom, then the reaction will be electrophilic, and if multiple bond is present between two different EN atom, then the reaction will be of nucleophilic nature. Now find that multiple bond is present, and again multiple bond is present between two different EN atom. Multiple bond is present, okay, this is multiple bond is present and between two different atom, then the reaction will be confirmed, that is reaction will be nucleophilic. Now you have to confirm that reaction will be nucleophilic confirm, but you have to confirm again that addition or substitution. How you will confirm? You are knowing that addition, nucleophilic addition reaction is when your Z group is bad leaving group, okay, and substitution when Z is your good leaving group. Now you have to find Z. This is your Z, okay. I am in reaction, I have shown that this type of that Z. So this is Z, okay, this is Z, Cl. And Cl is a good leaving group, because in bad leaving group we have discussed about H and CH3, H and R, total R, okay, H and R. If H and R is present, then the reaction will be addition, and you know aldehydes and ketones give addition reaction, not substitution. And if other than aldehyde and ketones and another acid derivative, it is your acid halide Cl group. So here R group is present, but on either side you have to look. Here Cl, it is a good leaving group, so the reaction will be substitution. I have finalized that reaction will be substitution. So you have to think this much when you are encountering a question in your examination. If you are able to think so much, if you are encountering any question, then be sure that you are going to score very high marks in your examination, in especially organic chemistry, if you are able to think so much. Okay, that we have identified nucleophilic, electrophilic, we have identified nucleophilic addition or substitution. Clear? So I am again telling, this is a basic thing. If you are going to learn this video, 100% you are reducing heaviness in your organic chemistry by 50%. I am telling that much. Now we are going to form product. If you are able to identify the type of reaction, you are easily going to form product. This is your nucleophilic substitution reaction. So first reagent your H2O. Okay, H2O, I frequently said that H2O is your nucleophile because it has lone pair, oxygen has lone pair, but lone pair in which condition? After completing its octet. Oxygen has octet complete, first condition octet is completed in oxygen, second condition is lone pair. If lone pair is present after the completion of octet, then that molecule will be considered under nucleophile. Now, so this is nucleophile, this will attack here because here delta positive charge is present, here delta negative charge is present, this will be attack. Okay, the bond will open. So this is your CH3 CO minus, okay, Cl and H2O like this. But you know oxygen generally forms two bonds, because if oxygen is going to form three bonds, then there will be development of positive charge here, and positive charge on a high EN atom like oxygen is quite unstable. So oxygen will remove its one bond. Okay, one bond is removed and this oxygen charge is neutralized here. Okay, now oxygen minus will come here. Okay, will want to form double bond, and it can form double bond because we are discussing the reaction of nucleophilic substitution, because Cl is a good leaving group, so Cl will leave quietly and the product will be your CH3 C double bond O OH. Clear? So this is the basic product in the first reaction. Now we are moving for the next reactions. Okay, clear? So this is the basic idea you have to develop. Now I am going to solve second question. The reagent is same, CH3 C double bond O Cl. You can put the reagent this anyone. CH3 C double bond O Cl. The reagent will be your C2H5OH. Okay, lone pair here present. Now I have told this reaction will be nucleophilic substitution reaction. Okay, how I have identified, I am not again going to tell that. Okay, because same reagent is there, same reactant is there. Now this electrophile, this is electrophile. Oxygen has lone pair after completion of octet, so it will attack here. It will open the bond CH3 CO minus, okay, Cl, and bond is between O2H5, because this H will be removed because oxygen will get positive charge, so it will remove that H. Now oxygen will negative charge will come here, Cl will leave there. Okay, the product will be CH3 C double bond O C2H5. Clear? Now you can easily solve all the questions given here. So you have to solve all the questions given here. Okay, mind it. One more thing I want to learn. This is the question in which, see here, NH2OH means oxygen has a lone pair, nitrogen has also lone pair. Nitrogen octet is complete, oxygen octet is complete, so both can donate electron. So you have to take electron from that atom whose En is less. Okay, so your nitrogen will donate the electron. In CH3COONA, which will be your nucleophile? CH3COO minus will be nucleophile. So this will be the attacking molecule in this reaction. Okay, so this is all about your nucleophilic substitution through addition and elimination. One question is left in nucleophilic substitution through addition and elimination. We will do in separate video. Okay, so thank you for watching. Best of luck. If you have learned something from this video, please tell us in comment box, and please don't forget to like the button and don't forget to share this video with your friends. So thank you for watching.